Hello, my name is Michael Newert, and I am an EMF test engineer and consultant. I have been working as a professional in this field since 1992. If you want more information about our EMF training videos and e-courses, please go to our website, emfcenter.com. Today I'm going to be showing you an actual client case example, a case I have worked on for over a year, fairly complicated, where we have reduced the radio frequencies by 99%, which is quite good, for a relatively challenging room to deal with. So we're talking here about a Faraday cage type of shielding strategy where we have all the directions shielded, above, below, all the sides, all around, the openings, the window glass. And it's complicated because this particular case has a lot of window glass, even above and on two of the sides, and a lot of openings. So it's a very challenging situation. We have significant radio frequencies coming into this home from a lot of different directions. So we're talking about an apartment with levels coming from below, radio frequencies coming from above, cell tower fields in front of that building, cell tower fields from the rear of the building, neighbors to the side, multiple sources, very challenging. And so I'm going to be showing here how we got to 99% reduction for this particular actual client case.
Step number one is to test the EMFs and begin to figure out some of the sources. So for this apartment, we tested the electric fields, the magnetic fields, and the radio frequency fields to determine what might be a good approach. And there were lots of sources. The magnetic fields were quite low. The electric fields were actually fairly high due to what we discovered is the old knob and tube type wiring. And the radio frequencies were the biggest concern. We had radio frequencies coming in from the north direction was the strongest fields, and that had to do with some cell towers nearby. There was a little bit also coming in from the other direction, the south direction at the back of the house, but there were radio frequencies coming from neighbors above, neighbors below, neighbors to the sides, and also then, of course, as in many cases, some of the strongest sources were right in the unit itself with their own wireless devices, in this case a wireless gateway for their internet service and a Wi-Fi hotspot in the hallway of the living room. So before going too much further, step number two was to eliminate the wireless devices inside the apartment. And if we're going to do any shielding, that's a good thing to do anyways, because all of these shield materials tend to do some reflecting. Some of them do almost 100% reflecting of the RF. And so if you put in shield materials, you're reflecting away what was coming in from the outside, but any sources inside reflect back to you and can make it worse, especially the more you're doing a Faraday cage and the more that you're shielding around you, the more important it becomes to remove the wireless devices in the unit. So the first step was to get rid of the wireless devices and put in wired-only equipment for them, and that was no problem. And then let's look at the EMF levels that we actually measured with those wireless devices removed. So I'm just showing two of the rooms. The master bedroom was the main concern, and there we can see we had fairly strong radio frequency fields. The magnetic fields were actually fairly low for something in the San Francisco Bay Area like this, in a downtown area. And the electric fields, though, were higher than average. So one of the interesting things was, as we went through this, we noticed that the sunroom, and the room on the other end of the house, had the lowest level of radio frequency fields, had the lowest magnetic fields, and had the lowest electric fields in this house. A lot of parts of the house were much worse than 3 volts on the skin. So, step number 3, the owners themselves, even before my input, just seeing that the levels were lowest in the sunroom, and that's also where my client felt the best, they decided to change their bed location to the sunroom. So this is often a solution for many people. Rather than doing any kinds of shielding, the first thing is, can you relocate or do something simple like that? So they relocated the bed to that room. But interestingly, Step number 4, there was an interesting thing that happened in a year's time, where you can see here between February 2018 and April 2019, the radio frequency fields greatly increased from both directions. So we had quite an increase, which had to do with more cell antennas going up closer and closer to this in this urban area. So now, where the sunroom had been something that had been at a relatively low level, now that level was up quite high and was even higher than the master bedroom had been the year before. So the decision was made to do some Faraday cage shielding of the sunroom. The sunroom was still our best choice for shielding because it was still the lowest field location in the house. And when you start out with a lower field and you get a certain percentage of reduction, you get down to a lower level. So when you do shielding, the lower the original level is, that means after the shielding, the better the result will be. So in this case, we decided to do Faraday cage shielding of the sunroom, which is challenging, because for Faraday cage shielding, you have to do all directions. And in this case, the room it's a sunroom. It has glass on the ceiling, glass on 2 walls, and there are also some fairly big openings into the kitchen and dining room, so that it's not as simple just do shielded paint on the walls. It's actually much more complicated. So this seemed like a good example for this case to show you. Step number 5. The first step was to shield the floor. And here we're shielding from both the radio frequencies and the electric fields, because some of the strongest electric fields were coming in from below. And in this case, we shielded the entire sunroom floor with a copper taffeta fabric. It's a special kind of shielding fabric. It's very conductive. It's very good for shielding electric fields if you ground it, and it's very good for shielding radio frequencies, and it's one of the lower cost materials. We could have even used something like aluminum foil, but we wanted something strong. And we could have used aluminum window screen, but this is going on top of a hardwood floor, and we didn't want to ruin that hardwood floor by putting window screen that might kind of grate or people walking over it with time. So we chose this copper taffeta fabric. Here you can see we've started installing it on the floor. We're basically taping it down a little bit so it doesn't move. And you can see it even looks like it's has a lot of copper in it, so it looks kind of coppery. But we're going to cover this up. It's on a hardwood floor, and if there had been a rug here, we could have just lifted up the rug, put down aluminum window screen, grounded it, and put the rug back. But in this case, we have a hardwood floor, and we want to keep that floor in good shape for the future. So in this case, we're putting the copper taffeta fabric on the wood floor, and we're going to put a wall-to-wall carpet on top of that. Here you can see where we finished the pieces of copper taffeta are covering the whole floor. And then most important is the grounding. In some cases, you do not need to ground the material. It's not so important if you have very low electric fields. But half of our purpose here is for reducing electric fields. And if you have electric fields around you and you do not ground the shielding materials, those shielding materials can actually make the electric fields worse. Depends on the situation. But if you have ungrounded shielding materials and there are some high electric fields around, you may be stopping the radio frequencies, but you may be making the electric fields worse. So in this case, we have a green ground wire. At the end of that ground wire, under that tape, I have stripped away the green plastic insulation. So there's 12 inches of exposed copper wire taped right down to that copper taffeta fabric. And in this case, as you can see that electrical outlet there, we're grounding this to the electrical system. Now, this is not ideal. We're doing it in this case because it's on the second floor of this building, and there's a lot of issues with getting ground wires into the earth down below because there's so much concrete below. But it is better if you can run a ground wire to a separate ground rod in the earth rather than use the electrical grounding system like this, because the electrical grounding system is dirtier. There's some voltage, some signals on it, and we're better off having a really clean grounding if we can, which is usually the best you can get is a ground rod to the earth. And in fact, for this client, if they are still having any issues with EMF sensitivity after the shielding is done, at some point we will modify this grounding, and instead of having this green grounding wire plug into that outlet, we're going to extend that, take it out through the wall, and go down to a grounding wire, grounding rod in the earth. So that's something that may happen at some point. Step number 6. The next step we took is to do Y-shield painting. This is a shielded conductive paint on the walls, and this was both for radio frequency purposes and for the electric fields again. If you look at this diagram in those dark gray areas, there's only 3 small wall sections there. They all have electrical in it. They're all emitting electric fields, and so we're going to put the Y-shield paint on those walls, and part of that purpose is also to be part of our Faraday cage for the radio frequency shielding. But the most important thing is here is we're putting on this conductive paint to stop the electric fields. And as we'll show you in a minute, that paint needs to be grounded. Just like the copper taffeta fabric on the floor, this paint needs to be grounded. And it's the same thing again. If you do not ground it, you may have success reducing radio frequency fields, but you may actually make the electric fields worse. So the reason for grounding is mostly for the electric fields, to make sure we're actually shielding the electric fields, not amplifying them, which is what happens if you do not ground the shielding materials. Here's an example of the paint. There's different paints out there now. When I began this work in the 90s, there was actually nothing out there except for these kind of toxic, very smelly commercial paints. So this is the paint I've been using ever since it came out many years ago, Y-Shield. It's a German product. It's very low VOC. It's water-based. I find for most cases you need to put on 2 layers, and this is the paint we used. There are other alternatives out there. I do recommend generally you use one of these graphite carbon-based types of paints. There are other manufacturers, and to me, when I look at the specs, they look pretty similar, and I even suspect that in some cases, because the packaging is almost exactly the same and the labels, that actually one manufacturer is making a lot of these and different people are putting their names on them. And one of the things about this painting process, it all needs to be continuous, so that even if you have to go around corners, you may even need to add a layer or 2 of paint at the corners, inner corners and outer corners, because we need the paint to make a transition so that it's all connected electrically, so that if it's like electrical wire with the paint connecting past the trimming here and then back to the wall, it needs to make a good connection from one surface to another so that the conductivity will go from this surface to this surface. So I can ground one place, probably under the computer here, and then that paint touches this paint, touches this paint, touches this paint, and then it's all grounded. In fact, in this case, if we go back for good shielding purposes here, actually we want to paint from this corner and around to here. So on this wall here, here's the light, you want to paint all the way to here and then around the corner to here. So we have shielding going all the way, because the shielding fabric is going to be on this side. This way the painted wall comes about there. Unfortunately, I do not have any pictures or videos of the actual painting process for the shielded paint on the walls here. But basically we used 2 coats of the Y-Shield paint, and because that's black, that is covered by 2 coats of regular paint, the chosen color of the client. And of course, to ground this, there's different ways to ground the paint. What I recommend for you is, like shown in this picture here, something like this supplied by Y-Shield. You actually get a grounding plate, and you can follow the instructions so that any electrician or even handyman typically can attach this plate properly to ground the paint. We don't have to go more into that here, but basically you usually buy a kit to ground the paint. Then the next step in the shielding process was the shielding curtain. This is basically for the open areas to the dining room and the kitchen that are between these small painted walls in this particular apartment. The shielding curtain is very important. We used a daylight fabric. Daylight is the name of the material. It's a lower end mesh material. What I like about it is it has fairly big openings so that you can see through it and a lot of air can come through it. That was important for this client. And also that shielding direction is not the direction that we have the most fields coming from. So we're using this as compared to some of the other materials. Also in this case, the daylight, in our case, we don't have to ground it. And daylight would not work for a material if you needed to ground the shielding. And because we're doing a good job of removing electric fields and adding shielding where needed for the electric fields, our shield fabric no longer has to do the job of shielding the electric fields. So we can use a simpler fabric that's not necessarily conductive on the outside. All the shielding fabrics are conductive on the inside. So the one we're probably going to use here is Daylight, which has the metal fibers on the inside and then cotton around that. So it looks better. It's actually a little safer because it's not so conductive to the touch. So that's kind of perfect for this situation. But we're going to be hanging it up here via a curtain rod or more permanently hung. And probably what we'll do is we'll probably have it split in half down the middle and with a little bit of overlap so that the homeowner here then can take each half of it and pull it back here and have it hung behind some kind of curtain holder on the sides. So the light still comes through really well, but then at night that can just be taken off the hook and hang here. So I want like about a 6-inch overlap or more between the two pieces that hang down on this archway. And here is what that shielding fabric looked like after it was hung. In this example, we have it parted for daytime use, but basically the owners would unpart that and put the two pieces together. And you can see it doesn't stop very much light at all. A lot of light comes through. The next step was finishing our Faraday cage by using aluminum window screen on the glass areas. So from this picture where you see the dark blue to the west and the south of the sunroom, these were large window surfaces also on top. So this was a major, perhaps the most important part of the radio frequency shielding strategy in this case. In this picture, you can get an idea of the challenge here. You have window glass on one side, then the other side, and then above also. So not an easy thing to shield. How do you shield all that glass? So in this picture, you can see, if you look at that second story, we have used aluminum screen that is basically stapled to the building from above, going over the glass at the ceiling of that room and then down the side. Now this wouldn't work in some cases, but in this particular situation, it's the backyard of a house. Nobody hardly sees it. There's a big tree in front of it. It's relatively well hidden, and the neighbors would not care. And the owners were okay with this. This is a very low-cost way to get really good shielding. Aluminum screen actually does quite a good job on most of the radio frequencies, and it's very inexpensive and very tough. So in this picture, you can see another view where you can see the two sides and how we've simply stapled this aluminum screen to the exterior of the building. This will last for several years. Now when the owners want to repaint, or if there's any other kind of work they want to do, they may need to take this off, or after a certain number of years this may fall apart or have trouble because of wind and different conditions from being outside. But it was a relatively low cost installation for this shielding on these two sides and the top of the sunroom. So this is something that may have to be fixed in a couple years again, but for now it'll probably work for several years with no problem. And the final results in this picture again, you can see, you can barely tell that there's aluminum screen over the top and on the two wall surfaces where the windows are. You can barely tell, a lot of light still comes through, and it's actually fairly beautiful still. So the final step is to do the post-testing of the EMF levels. You always want to check that you have actually reduced the fields, not missed something. We always do a post-test. And here you can see, if you look at the yellow highlighted there for the sunroom, just how much the radio frequencies have reduced from 6,600 microwatts per meter squared just before this shielding strategy was installed to after, just a few weeks later, now with the shielding down to only 70. Quite a reduction. And for the electric fields, similar, where we used to be in the range of over 1 volt on the skin, now it's down to 0.25. So let's figure out our shielding effectiveness. For the radio frequencies, here I've listed in this chart before and after for the sunroom, and I've converted also into the other units. The microwatts per centimeter squared is the typical US American units, and the volts per meter is another type of unit that some meters measure in. So basically, if you take the 6600 minus the 70 you're left with divided by 6600, that gives you the percent reduction, and in this case it calculates to 99%. That is quite good. In the real world, it is difficult to get much better than 99%. Even if the materials are 99.99999%, there's always like little gaps or little issues. So 99% in reality is quite good. Very happy with that. And for the electric fields, we also have some reduction. The electric fields were not so high in this room. And with the shielding strategies here for the electric fields, we've gone from 1.16 volts on the skin down to 0.25 volts on the skin. And that percent reduction comes down to 78%. But if you consider where originally the people here had been sleeping in a stronger electric field, I believe around 3 volts, that this percent reduction is actually much better if you consider where they used to sleep to where they sleep now. From 3 volts down to 0.25 volts, you're talking over a 90% reduction of the electric fields from the old sleeping place to the new one. And here finally again is the picture of the beautiful way that this turned out. Actually quite nicely, the new paint, the new curtains, the aluminum screen on the walls. You don't even see the shielding on the floor. It actually turned out quite well. And for these clients and for most people, this kind of approach is usually much better than a bed canopy. The limitations of a bed canopy are that they're smaller, they're actually more hassle, and you can only use them while you sleep. While when you're shielding a whole room like this, you have a bigger space, it's more beautiful, less of a hassle, and there's much more usage of the room. And in fact, in this case, the computer is in that same room, and sometimes the clients can sit there during the day. It's kind of a refuge place now, kind of an EMF safety zone in the house that can be used not just for sleep, but for all parts of the day. Thank you again for joining us so much for this video. If you would like to see more EMF videos or find out about our e-courses and training courses, visit us at emfcenter.com.